The James Webb Telescope has just sent a shocking message that has left all NASA scientists silent. The largest optical telescope in space has been observing different components of our vast universe for years, revealing various phenomena. However, the recent image has sent shockwaves through the world of science and astronomy. What terrifying image has the James Webb Telescope captured? Could it have photographed an alien space in the far reaches of space? Join us as we explore the terrifying new images that the James Webb Telescope has just revealed. Images we have never witnessed before. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. NASA's 10 billion James Webb Space Telescope was launched from the European Spaceport in French Guiana. Once it arrived at its new cosmic home, this infrared observatory has provided stunning views of the cosmos to scientists and astronomers. As the largest and most advanced space telescopes to date, scientists were thrilled to see the first scientific images captured by the telescope. However, what they saw nearly left them petrified. When the James Webb turned its instruments toward the iconic pillars of creation, it captured the famous dust clouds in incredible detail. These pillars are located in the constellation Serpens, about 7,000 light-years away from Earth. The pillars of creation are part of the Eagle Nebula, large clouds of gas and dust that was first photographed by the Hubble Space Telescope in 1995. Since then, the extraordinary beauty of the pillars has been revealed. The new photograph captured by the James Webb Space Telescope reveals the pillars of creation in even greater detail. Several stars are visible that were not visible in the previous image captured by Hubble, some of which formed only a few 100,000 years ago. This represents a remarkable scientific breakthrough, but on reflection, it's not possible to say with certainty whether they are direct constructions of extraterrestrials. The James Webb Space Telescope has also scanned the so-called Pandora cluster in a stunning image, taking its cue from the Greek mythology of Pandora, whose curiosity led to the opening of a vessel that released all the evils and hardships in the world. The analogy applies here. However, in this case, the James Webb Telescope has done something similar by focusing on a specific region of space called Pandora's cluster, an idea predicted by Albert Einstein in 1915. These new images perplex scientists as they reveal details they were unaware of in this region of space. However, it is important to know that this area of space has a formal name known as Abell 2744, which is part of the Pandora cluster. This cluster arises from the observatory of a variety of distinct structures within it. What is fascinating about this image is that it's been observed before, but only the central core of space has been studied by the Hubble Space Telescope. This implies that many significant secrets remain to be discovered in this intriguing region of space. Until the James Webb directed its powerful infrared instruments into the area to observe the Pandora cluster, the observing team employed the Large Telescope's near-infrared spectrograph and near-infrared camera as part of the Deep Observation program. Prior to the ionization epoch, 4 snapshots were taken and then combined into a panoramic image. This panoramic image revealed approximately 5,000 infrared light sources in the Pandora cluster, which is about 3.5 billion light-years away. The image captured by the James Webb Telescope achieved an impressive balance between depth and breadth, which could change our perception of galactic evolution. A highlight of the image is a bright foreground star in the Milky Way, which unique diffraction peaks produced by the James Webb Space Telescope. Also visible are bright sources of white light surrounded by a hazy glow, corresponding to much more distant galaxies within the Pandora cluster. Although human-developed technology is crucial to the observation of this galaxy cluster, astronomers also relied on a natural phenomenon proposed by Albert Einstein in his theory of gravity known as general relativity, published in 1915. In addition to fascinating discoveries that excite scientists and astronomers, the James Webb Telescope has captured strange space phenomena that even scientists cannot fully explain. One such enigma is the mysterious concentric rings found around a distant star, which have yet to be fully understood by astronomers. The image was posted on Twitter by a citizen scientist, which generated a torrent of comments and debate among the user community. The image showed that a star called WR140, surrounded by regular wave-like circles, that gradually faded away. What was striking, however, was that the circles were not perfectly round, but had a somewhat square appearance. This immediately gave rise to theories about a possible extraterrestrial origin. However, some scientists argued that it was just simply nature performing something that seemed impossible viewed from a single point of view. Sometimes natural phenomena may seem extraordinary from certain perspectives, but have simple explanations. Nevertheless, questions remain. Why do they have that particular shape, and why are they so regular? These questions have troubled scientists like Smith, who was not the only one concerned about these puzzling images. Mark, an interdisciplinary scientist with James Webb Science Working Group and a science advisor to the European Space Agency, called the feature wacky in a Twitter thread. He explained that the six-pointed blue structure is an artifact due to the optical diffraction from the bright star WR140 in the image. However, he noted that the red curvature is real and represents a series of shells around WR140 in space. Although NASA is expected to have something to say about this, it is expected to make a statement soon. In general, young stars tend to glow bright blue, while over time, they take on a more reddish glow as they consume their fuel and cool. Astronomers did not expect to see old red stars in the ancient galaxy for which the James Webb Space Telescope was built. Nor did they expect to find more massive galaxies that could be up to 1 billion times more massive than the Sun. These red dots revealed in the images captured by the James Webb Space Telescope appeared to be 50 times more massive, according to Joelia. The most massive galaxies in our sample are estimated to have masses between 2 and 4 times less than that of the Milky Way. This discovery is astonishing, since galaxies as massive as ours were found when the universe was only 3% of its present age. Leah also mentioned that before astronomers start rewriting cosmological theories to explain how these galaxies came together so quickly after the Big Bang, they will need to make sure that the strange red dots they are observing are not something else. However, most alternative explorations would also require entirely new concepts. For example, stars in the early universe could emit light in exotic ways due to a lack of heavy elements, which are not incorporating into our models. The images that revealed these puzzling galaxies were obtained by Webb's near-infrared camera as part of the Cosmic Evolution Early Release Science program. The team plans to return soon to these galaxies and the Road Mirror to obtain spectra of light from distant points. The spectra decompose the observed light according to its composition into wavelengths, thus revealing the chemical and physical properties of its source. Most importantly, the spectra provide very precise distances to these objects, Leia says. The distance and identity of these objects are correlated, and if we know the distance, we can pinpoint the identity and vice versa. A spectrum will tell us fairly immediately if our hypothesis is correct. Just 6 months after Webb's teams made the first observations public, scientists are being forced to rewrite their theories about the early universe. Observing the early universe for the first time led us to find something so unexpected that it actually poses problems for science in general, as it calls into question the whole picture of early galaxy formation. Another amazing image captured by the James Webb Space Telescope shows the Ghost Galaxy, which looked like a wormhole spinning before our eyes. This new image, based on deep space data, highlights the dust lanes of galaxy NGC 628, or Messier 74, known as the perfect spiral because of its symmetry. The ghost galaxy is interesting from a scientific point of view because of the intermediate mass black hole that scientists believe it's at its core. Although the ghost galaxy has been imaged numerous times, including by space observatories such as the Hubble Space Telescope and the Wide Field Infrared Survey Explorer, the Webb images stand out because of the near-infrared range that reveals cosmic dust, combined with the power of its unique 18-segment hexagonal mirror and its location in deep space. Since time immemorial, we have built our own cosmological model based on observation, theories, and mathematical foundations, and there are indications that the universe does not agree completely. You may be aware of the cosmological crisis, which arose due to discrepancies in the measurement of the age of the universe by different methods. Cosmologists are puzzled by these inconsistent results, a situation that has been exacerbated by recent images captured by the James Webb Space Telescope. The universe is undergoing an expansion, with distant galaxies moving away from us. One method of calculating the expansion rate is based on the cosmic microwave background, which gives us a certain rate. Another method involves observing the brightness of distant supernovae, comparing their expected brightness with the observed brightness to estimate the expansion rate at the time of the supernova. This method, known as a standard candleas, shows a different expansion rate. The expansion rate of the universe is consistently referred to as the Hubble constant. The discrepancy between the results of these two methods is known as the Hubble tension, which is at the heart of the cosmological crisis. However, this is not the only problem. There is a new critical situation in the cosmological realm that seems to be a distant variant of the crisis facing cosmology. It is like that distant relative to which we hardly pay attention. Years have been spent developing a scientific theory about the universe, and now that theory is coming under scrutiny. But that's how we move forward. That's how science progresses. When we look up at the sky, away from the cities and places that obstruct starlight, we see the Andromeda Galaxy as a tiny dot in the midst of countless stars. This is because the universe is full of stars and galaxies, but the question is, how much of this matter actually occupies any part of the universe? How much matter is there really? These are simple questions, but their answers are far from straightforward. This dilemma persists largely because of the current cosmological observations, which do not agree on the distribution of matter in the universe. This discrepancy has given rise to the S8 tension, also known as the discomfort associated with the measurement that now troubles us. The S8 tension is a measure that evaluates the clustering or accumulation of matter in the universe. To simplify it, think of the universe as a huge jigsaw puzzle, where the pieces represent matter dispersed in space. Space scientists seek to understand how this matter is distributed and how it clumps together. There are two approaches to measuring this. First, an accurate measurement is made through observations such as gravitational lensing. Gravitational lensing is a phenomenon where the immense gravitational pull of massive objects, such as black holes and galaxies, acts like cosmic magnifying glasses, bending and distorting the light from distant objects that would otherwise be invisible. This phenomenon gives us a broader view of the vast universe. However, the SA value derived from the second approach, based on the standard model of cosmology using measurements of cosmic microwave background radiation, differs from observational derived values. This discrepancy is at the heart of the mysterious SA tension, where there is clearly an element that defies our understanding, challenging the agreement between numerous theoretical observations and hypothetical entities that support these theories. To unravel this enigma, one of the world's most powerful supercomputers has been used to perform cosmological simulations. The magnitude of this project is evident when considering that part simulations required more than 50 million hours of computation, distributed among the 30,000 processors of the supercomputer at Durham University in the United Kingdom, nicked Flamingo. This project, with its complex acronym denoting the complete interpretation of large-scale structures and detailed mapping of the sky for the interpretation of next-generation observations, stands out not only for its immense size and resolution, but also for its comprehensive approach, which is distinguished from previous simulations focused solely on modeling dark matter. Flamingo goes beyond considering gravity alone. For white dark matter makes up most of the mass of the universe. Ordinary matter, despite representing only a fifth of the total mass, exerts a significant influence on the distribution of matter on smaller scales. Factors such as galactic winds, driven by supermassive black holes and supernova explosions, can affect the formation and evolution of galaxies. Unlike previous simulations that focused solely on dark matter, Flamingo incorporates and tracks ordinary matter, recognizing that although dark matter dominates gravity, the role of ordinary matter cannot be underestimated. Despite remarkable advances, these simulations represent a step forward in our understanding of the formation of celestial bodies, such as the Milky Way and the Andromeda Galaxy. Flamingo, on the other hand, fails to explain the sparse accretion of matter in the present-day universe, which means that it does not solve the very problem it was created to solve. For example, to help resolve the SA tension. In other words, the Flamingo simulation suggests that something is deeply inconsistent with our standard model of cosmology. Moreover, they contradict observations made by the James Webb Space Telescope and other observatories regarding the distribution of matter in the universe. Although these simulations provide detailed insight and consider the role of supermassive black holes, they fail to accurately predict the actual distribution of matter. They indicate that galaxies evolved in a certain way, but there is a mismatch. They predict that they are 7% more densely clustered than they actually are. Although this new computer simulation is much more detailed and covers aspects such as the impact of supermassive black holes, it also does not match reality, indicating 5% more crowding than observed. This is a major breakthrough for science, as it shows us that there is still much to be discovered. This discrepancy indicates that significant revisions to our current cosmological model are required. This process is typical in science, anticipating a major challenge that is already looming on the horizon. This mismatch between computational simulation and actual observations has provoked intense reflection in the scientific community. The existence of 5% more crowding than predicted raises fundamental questions about our understanding of the cosmos. Researchers are at a crucial juncture, facing the need to revise and adjust our current cosmological framework to account for these new observations. Science, at its core, thrives on the discrepancies between theory and observed reality. It is a powerful reminder that even with advanced computational models and rigorously tested theories, the universe always has surprises in store. These moments of dissonance between our predictions and what we find in the cosmos are the engines that drive innovation and scientific progress. Exciting and challenging times lie ahead for cosmology and astrophysics. Scientists are engaged in the task of evaluating and reformulating theories to accommodate these new observations, seeking to better understand the fundamental nature of the universe. This process of revision and change is inherent to science progress and often marks the beginning of revolutionary discoveries that profoundly alter our perception of the cosmos. Our universe is constantly expanding, making it difficult to establish its limits and measure its size. However, thanks to the James Webb Space Telescope, we can now glimpse into the farthest corners of the universe. Since the James Webb Telescope began its exploration, numerous scientists such as Brian Cox have made announcements revealing the true size and vastness of the universe, which is almost unimaginable. Within the fragment of the universe that we can observe, there are approximately 2 trillion galaxies. This estimate is based on studies of the local universe. We are quite sure that this portion we can see is only a small part of what we could be an infinite universe that we do not yet know. We are not separate from the universe, but we are an integral part of it. We are in a way in which the universe knows itself. With the help of the James Webb Space Telescope, we plunge into a vast exploration to discover the true size of our universe. If you're interested in keeping up to date with news about the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. If we were to travel at a speed of 70 miles per hour, it would take us about 15 days to complete one lap around the Earth's equator. It would take approximately 5 months to reach the Moon, 63 years to reach Mars at its closest point, and a staggering 4,400 years to reach Neptune. These figures alone demonstrate the immense scale of our solar system. To put this in context, we consider the Voyager 1 probe, launched in 1977, at a speed of 38,000 miles per hour, and did not leave the solar system until 2012. This means it spent 35 years just to get out of the solar system. Even light, which can circle the Earth 7 times in a single second, seems relatively slow compared to the vastness of our solar system. And although our solar system is vast, it is dwarfed by the enormity of the Milky Way galaxy. This galaxy contains approximately 300 billion stars, each of which probably has its own planetary systems. Our nearest neighbor star, Alpha Centauri, is 4.3 light years away, which means that if we were to travel at the speed of light, it would take us 4.3 years to get there. Now, imagine how long it would take for us to travel to the next star system, Alpha Centauri. Even if something were traveling at the same speed as the Voyager probe, that is 38,000 miles per hour, it would take a staggering 77,000 years to reach Alpha Centauri. That shows us the immensity of the distances involved in exploring the cosmos. Now, let's focus on Betelgeuse, a star located 640 light years away. If we consider what we call radiosphere, this represents the distance of our radio transmissions have covered in the last century. Although the signals have degraded significantly, they have so far reached about 15,000 star systems. However, this figure is only a fraction compared to the number of stars in the Milky Way, and there is Betelgeuse. If you look at Betelgeuse in the night sky tonight, you are actually seeing the light that left its surface 640 years ago, about 100 years before Columbus set sail for the New World. This light has traveled for all that time, and it's just now reaching our planet. It is truly amazing to realize that Betelgeuse, on an universal scale, is relatively close. To surprise you even more, we must consider that our radiosphere, which encompasses all human radio transmissions, is only a small dot in which the immense expanse of the Milky Way. Let us help imagine this. If we were to reduce our solar system to the size of a quarter of the United States, the entire Milky Way would be comparable to the vastness of our planet. In this immense region, there would be about 300 billion star systems and their planets. We're just one of those 300 billion star systems floating in the midst of an unimaginably large number of stars and planets beyond our galaxy. At least 1 trillion more galaxies. Yes, 1 trillion. 1 trillion is an incredibly large number. To understand its magnitude, imagine a collection of 1,000 cats. Now suppose there are 1,000 groups of cats, each consisting of 1,000 cats. That will give us a total of 1 million cats. But to understand 1 trillion, we must remember that there is already 1 million represented in that number. So 1 trillion equals 1 million times 1 million, which is a staggering number of cats encounters. Our nearest neighboring galaxy is the Andromeda Galaxy, located 2.5 million light years away. Andromeda is rapidly approaching us at a tremendous speed. As this galaxy approaches, our night sky will undergo significant changes. This galaxy contains about 1 trillion stars, and when eventually collides with our own Milky Way galaxy, which has 300 billion stars, the chances of individual stars from both galaxies colliding with each other are quite slim. This illustrates the vastness of space and the low probability of direct interaction between stars within a galaxy. Galactic collisions, although rare at the level of individual stars, may even facilitate light between stars and galaxies. Galaxies are not static systems, but are dynamic and constantly evolving. As we move away from our galaxy, we find our local groups of galaxies, followed by the Virgo cluster, which contains more than 1,500 galaxies. And Virgo, in turn, is part of a larger supercluster known as Laniakea, which contains approximately 100,000 galaxies. Each of these 100,000 galaxies has hundreds of billions of stars and planets of its own. And this is only a small part of the picture. In the observable universe, there are another 10 million superclusters, similar to that. As we zoom out and observe, we discovered an increasing number of mapped galaxies, for example, determined galaxies. However, these mapped galaxies represent only a small fraction of what is really out there. There are a staggering number of hundreds of billions of galaxies that have not yet been fully mapped. In addition, we must consider the cosmic background radiation, which represents the oldest detectable light. For example, that is the residual heat left over from the Big Bang. This radiation is a remnant of the early stages of existence of the universe. The scale of the universe becomes even more staggering when we consider the vastness beyond the galaxies. We find regions in space known as cosmic voids, where matter is scarce compared to the rest of the universe. These cosmic voids are immense, spanning hundreds of millions of light years in diameter, and appear as vast expanses of seemingly empty space. However, these cosmic voids have the potential to give rise to the formation of future structures in galaxies. As we move deeper into the cosmos, we encounter cosmic filaments, which are colossal threads composed of dust, gas, and dark matter that stretched across billions of light years, connecting galaxies and galaxy clusters. These cosmic filaments form a cosmic web-like structure that binds the universe together in the gravitational interactions. The distribution of matter in the universe is not uniform, but shows a cosmic web pattern, where clusters and superclusters of galaxies are connected by these cosmic filaments. This creates an intricate tapestry that spans unimaginable distances. It is within these cosmic filaments and superclusters that galaxies congregate, interacting through gravity. The vastness of space offers a vast and abundant stage for the existence of countless celestial objects and phenomena. For example, supernovae, which are the explosive death of massive stars, disperse heavily elements throughout the cosmos, enriching the interstellar medium and the planetary systems. Black holes, with their immense gravity, play a determinant role in the evolution of galaxies and can release jets of energy that extend great distances into space. In the depths of space, we also find exotic phenomena such as quasars, which are supermassive black holes that feed on intermittent matter and emit colossal amounts of energy. These quasars can eclipse entire galaxies and act as beacons of the early universe, allowing us to study the cosmos in its early stages. However, the question arises as to what lies beyond the observable universe. There are numerous additional galaxies that beyond our visual reach, as the light from these galaxies has not had enough time to reach Earth. Furthermore, due to the continuous expansions of space and the constant motion of galaxies, the light from most of these distant galaxies will never reach us. As a result, these regions may remain inaccessible to us indefinitely. As the universe expands, we can make inferences based on our understanding of the laws of physics. These inferences suggest that the entire universe is at least 250 times larger than the observable universe. In fact, there are compelling arguments suggesting that its size could be even larger, potentially infinite. In this context, a broader perspective emerges that leads us to consider the nature of the universe and our place in it. As human beings on our remote planet, within the vast expanse of space, contemplating these possibilities invites us to reflect on our existence and our role in the cosmos. Have you ever wondered how vast our universe is? If so, I hope the video has helped you understand even a little bit more about the vastness of the cosmos. I hope you use the comment box to post any questions if you have any. And if you liked the video, hit the like button. Share it to reach more people and subscribe so you don't miss more content like this. Thank you so much for watching, and I'll see you in the next one.